So we're looking at scatter plots. We're going to create them in the calculator, and we're going to describe them. So here's our vocabulary. Scatter plot shows the relationship between two quantitative variables. They have to be numerically measured on the same individuals. So yesterday we did the candy grab. We measured your hand span and how many candies you could grab with your dominant hand. The values of one variable appear on the horizontal axis, and the values of the other appear on the vertical axis. Now we're not really saying x and y axis, because technically the x-axis has to have the origin on it, 0, 0. And we're not always going to include 0, 0 in our axis. The explanatory goes on the horizontal axis, and the response variable goes on the vertical axis. This table shows the number of pounds that 10 students in Mr. Lang's weight training class could bench press and squat. We're going to make a scatter plot to display the relationship between the bench press and squat. So we're going to need to open our calculator. Okay. Let me get mine. Here is a case where we could really let either one be the explanatory variable, right? Does your bench press explain your squat, or does your squat explain your bench press? It doesn't really matter. But the way the data is organized in this table leads me to believe that the bench press is going to be our explanatory variable and the squat will be our response variable. So you're going to go to Stat. Helps to turn it on. Hold on, I got to turn on this recording. So you're going to hit the Stat button, and then you're going to hit Enter on Edit. And I already have some data in here, so I'm going to go up and highlight L2, clear, and go down. Highlight L1, hit clear, and go down. Do not hit delete. It'll delete the list entirely. Okay. So Stat, Edit. And we're going to enter all of our bench press data in list 1. Okay, so 95, 111, 113, 125, 135, 45, 165, 180, 196, 95, and 111. Do I have? I count 12 values. Why did it say 10 students? Okay. Okay, so we're going to delete the 95 and 111. Just hit delete. But now I only have 9, so what did I skip? Oh, there's 2 180s. So, right, there's 2 separate 180s. So I'm going to show you how I can insert a data point, because the order in which we do this matters, right? So I'm going to go second, insert, above delete it says insert, and then I can put the other 180 in there, so that when I put in the y values or the stat, it's going to line up, right? If I put the other 180 at the bottom, I would have to make sure that the y value, the stat amount, or the squat amount, goes with it below. So you can insert and then you can delete values.
So I'm adding 3?
Yes, there's only supposed to be 10. These are the same. I don't know why this table has 2 of them. Okay. And then now let's hit over and put in your squat data. So if your calculator is missing any lists, go hit Stat, go down to Setup Editor, hit Enter, and then Enter again. And they should be back.
Why did we add another 180?
Because there's two 180s in my list with two different squat values. So I skipped over it. I forgot to put two of them in there. There's two people that can bench press 180.
Oh, so what if I already put in 180?
You're going to do second insert, put your second one in there. If you only have one.
Oh, I had two.
Okay, then you don't need to fix that. I know. I just had only entered one, so you don't need to fix that. 218, 284, 275, 338. Okay, so I should have all my data in the calculator. So I put the bench pressed in list 1, and in list 2, I put squat data. Okay. I'm just going to stop that for a second. It's only taking me this long to figure out that if I want it closer, I can lower this down and not have to hold the.
When did you figure that out?
Just now, I just realized that I can lower this instead of holding, like I used to hold the calculator up like this, instead of just setting it down underneath. Brilliant. Sometimes. Okay, do we all have our data in? Okay, so now we want to draw the graph. So we're going to go to stat plot where we drew histograms and box plots. So hit second stat plot. Okay. So second stat plot. And then you're going to hit, see, I have, notice here I have off, on, off, right? Yours might all be off. Yours might all be on. Let's go down. Let's just make sure I'm going to turn off plot 2. So I hit enter on plot 2. I'm going to highlight off. I'm going to turn it off. And then I can go up and highlight plot 1 and go back into plot 1. So make sure that you only have plot 1 on. Okay, we're going to leave plot 1 on. If it's not already on, go into plot 1 and hit on. You can toggle between the 3 plots by going back and forth between the ones at the top here. Okay. Okay, so we're here. We're going to hit enter on our list 1. The first graph type, if you notice, if it was on histogram, it's only asking for the X list. If I go to the first graph, that's a scatter plot. The second one is a line graph. It connects the points. We don't want the points connected, okay? And then we put our explanatory variable in the X list. That was our L1, the bench pressed. And then in the Y list, we put our response variable. That was list 2, and you can choose the mark you want. Then we needed to zoom around our numbers, so we're going to go zoom all the way down to 9. It's always going to be zoom stat, so that it re-centers around the numbers in the lists, okay? If you just hit graph, whatever you graphed last, that's going to go to those numbers, and there may not be any data there, right? Especially if we put in years, that is like 1900, and your last graph was in the 90s, you're not going to see anything. So you need to zoom stat. Okay, so there's my scatter plot. And then if you're doing this by Next, we're going to be asked to describe them. We talk about several things when we describe them. I had it all nice and typed, but for whatever reason, it did not import the actual words from the PowerPoint. So we'll do this by hand. We describe the direction first. Is it positive? Meaning the scatter plot's going up? Or negative? Scatter plot's going down. We always read graphs left to right, just like a book. Is it increasing from left to right, or is it decreasing from left to right? Positive or negative? We talk about the form. Is it linear? Kind of like a line. Is it curved? Maybe it looks exponential. Maybe it looks parabolic. Or is there no form? Which is really just a box of points. There's really no pattern to it. We talk about strength. In AP Stats, we say scatter. Which is how close to a line are the points. So tightly scattered would be almost a high, strong. Means the points are really close together. Moderate. Points are more spread out. Weak. Points are very spread out. And the last thing is outliers. So no form is the shape, and it's gonna have a weak strength. So no form is gonna be weak, right? So we're gonna put those together. If there's no form, it's a weak association. It's neither. Yeah, there is no direction because it's just a big cloud of points. Yeah. And then outliers are points that don't fit the model or pattern. They don't fit the pattern. Okay, this was our candy grab graph.
It's moderate.
So first start with your direction. What's the direction of this graph? Positive. What's the form? Okay, the strength is moderate. We can say moderately strong. It's pretty linear. I mean, I can draw a line through that, right? It's definitely not curving. up. Like it's a pretty wide line, but it's there. Do you think there's outliers?
Yes.
Yes, possible outliers. This is maybe an outlier. But you have this graph, right? In your notebook.
No, I mean like when you want us to.
When you're asked to describe, you're going to talk about these things. Positive or negative? Is it linear, curved, or doesn't have any shape? Is it moderately strong? Is it very strong? Is it weak? And then are there possible outliers? So yes, possible outliers, lots of outliers, no outliers. Okay? Yes, Kayla.
So if they're asking for the strength, moderate and weak are the types of strength?
Moderate and weak are types of strength. Yes. Strong, you'd be like very strong, strong, moderately strong, weak,
So is
or, yeah.
types of direction, like positive and negative, there's types of linear?
Yeah, there's type of shapes. The shape is either linear, curved, or there's no form. Okay. Okay, so let's get some more graphs.
Oh, wait, what?
This scatter plot displays the time, the time to run the 40-meter dash without shoes versus the time to run the same distance with shoes for a sample of 82 high school students. That is not what that graph is.
That might be income per person. That's what's going on.
Okay, now we have the right graph. Time with shoes, time without shoes. Okay, so take a second, write down what your description for this scatter plot would be. Okay, what would your description of this scatter plot be? Okay, so let's talk. What's the direction? Positive. What's the form? Linear. What's the strength? Strong, or you could say moderately strong, right? So you can combine two, right? The closer it is to a perfect line, it's strong, really strong. The more spread out it becomes, even if it's a line, the less strong it becomes. So you can even go on a continuum from like very strong to moderately strong to moderate, to moderately weak to weak. Okay? And we're going to get a numerical measure of that strength next week, next lesson, when we talk about correlation, which is a numerical measure of the strength. And then, are there possible outliers? Yes. This person is I would definitely call that an outlier, right? It doesn't follow the pattern. Okay? They're pretty fast. Look, they're about 6 seconds without shoes, but they're 8.5 with shoes, right?
But if there was like little outliers, you'd say possible.
Right, possible. If you had someone here, that would be considered an outlier. Okay, this one's probably a little too close to the pattern. This one, it's possible. That guy's an outlier just because he's kind of slow on the 40-yard, right? 40 meters.
On both sides, then you would just put outliers.
Possible outliers, yeah, or outliers. Okay. Here's the other thing we need to be able to say. Okay, because there's a positive relationship, we can say as time with shoes increases. This is explaining our relationship in context of the problem. Not just saying positive, linear, strong, whatever, okay. But what are we actually talking about? As the time with shoes increases, the time without shoes also increases. If it was negative, we would say as time with shoes increases, time without shoes decreases. Okay, as your x increases, what is your y doing? If it's decreasing, if it's negative, the y is decreasing as x is increasing. Okay. Okay. All right. Now this one. This is life expectancy and average income per person for 179 countries.
I think this is definitely curved.
It's definitely curved, right? It's positive.
It's a strong curve with some outliers, and I think it's negative. No, it's positive?
Well, it's
Oh, yeah, it is positive.
positive,
Sorry.
right?
I was thinking
Curved,
down.
moderately,
Strong. Oh, wait. Yeah, moderately strong.
and maybe some outliers.
Why do you say moderately? They look pretty tight.
Tight would be like all really close on this line,
Oh, okay.
right? So very strong is almost a perfect curve without any scatter. Okay.
Dang it, alright. Following that simple line.
Okay. So go ahead and describe these two graphs. Okay, so what was our decision for graph 1? Positive,
Positive, moderately strong. Or curved, moderately strong. Oh, wait.
strong. Look at how close the points are. If I drew a line, it's like they're almost all right next, like touching the line.
Oh, okay.
Okay, so that's strong.
So even if
And
it's moderate, you're just gonna say strong?
yeah, no outliers. As weight of the diamond increases, price in thousands increases. Graph B. It's negative. Guys, too much talking right now. Just give me a few more minutes.
Yes.
It's linear. It's weak.
Definitely weak.
No outliers.
0.
As dash time increases, it's always as x is increasing, what is y doing?
Decreasing.
It's decreasing. So long jump time, no, distance, decreases. I can't spell right now. Okay, so as the dash time increasing, they're not jumping as far, right? I mean, because they're slower in that initial run, right?